Alright, so if pressure increases, equilibrium will shift towards a lower number of moles, and then the opposite, if pressure is decreased, equilibrium will shift towards the higher number of moles. So we said that yesterday, we learned it yesterday, we did some practice problems in the notes, we did some practice for homework. That other worksheet I gave you due Monday, so both of those are due Monday. More practice with some of the pressure. Okay. Next is temperature. So I'm going to show you the next part of that video because it explains how temperature affects it. But the one thing I'm going to preface it with, is this good to go here? Yes, Zane?
Yeah, I should copy it off the top one.
Go ahead. It is important for you to be able to put the energy on the correct side. So if I say something's endothermic, which side of the arrow does the heat go on? It's endothermic. Reactant. If it's exothermic, it goes on the product. That's going to be really important to understand this whole balancing seesaw thing. So let's first write down temperature in our notes, and then I'm going to have you write some things down after the video. So let's see how temperature affects equilibrium, but I do want to make sure you understand if it's heat plus A plus B yields C plus D, that's endothermic. That's endothermic, so keep that in mind. And if it's A plus B yields C plus D plus heat, that's exothermic. So if the heat is on the right, it's exothermic. If it's on the left, the reactants, it's endothermic. Alright, so that's important to have in mind here. So let me show you the video, and then we'll do some examples, and then you'll have the homework for practice.
Question about the test, but I can't ask it.
Alright, just right after class. Can you guys, I guess pull those down, it's kind of gray, but let's get it nice and dark.
I'll get that today.
Luke's going to get it today. Thanks, Luke. Hey, did you give me a review book?
Oh, I can't find it. I think it's my locker.
Wow. Really?
Real dark.
Honestly, look at your glove thing. Look at it.
Glowing.
That's crazy.
Thanks. Alright, here we go. So, LeChatelier Principle Part 2, here we go. About 3 minutes.
In this lesson, you will learn about how a system at equilibrium
She's very clear.
responds to changes in temperature.
Yes.
LeChatelier's principle states that a chemical system at equilibrium always works to restore equilibrium when it is stressed. To consider what happens to a system at equilibrium when temperature is changed, you must first consider the energetics of the reaction in question. If the forward reaction is exothermic, then the reverse reaction must be endothermic. Let's examine this hypothetical reaction where reactant A reacts with reactant B to produce product C and product D with a change in heat of minus 75 kilojoules.
That was weird. Her voice don't change that. So, maybe she's possessed. So, the negative 75 indicates that it's exothermic. So, stay with me. If this was to be written in the reaction, it would be over here, plus 75. So what she said beforehand is really important for you to understand. If the forward is releasing 75 kilojoules of heat, the reverse is going to be gaining that energy. So it's opposite. So the point that I'm making here with this is when we learned about these diagrams, I don't know if you guys can see that, but if this direction you're losing heat, well then that direction you're gaining it. It's the same diagram. So these potential energy diagrams you just took the quiz on, that diagram doesn't change if you walk, again, imagine you're standing on the curve. If you're walking left to right, you'll end up going down, okay? But if you're walking right to left, you're going to end up going up. It's the same curve. So I'm really stressing that you understand this direction you're negative, but that direction to be positive. And that's important to understand with this whole equilibrium stuff. Okay.
This means that when the forward reaction occurs, 75 kilojoules of energy is released and 75 kilojoules is absorbed when the reverse reaction occurs. So an increase in temperature would mean that the endothermic reaction would be favored to remove the excess heat.
So, if you increase temperature, the endothermic reaction is favored. So every reaction, and you can write that down. I would like you to write that down. I'll say it again. If you increase temperature, the endothermic reaction is favored. The endothermic reaction is favored. That may not make a lot of sense yet, and that's okay. We're going to finish watching this and do a couple practice problems. So, again, what does that mean? Well, all reactions are either exo or endo in the forward. The reverse is going to be the opposite. So if going left to right is exothermic, then going right to left is endo. If we increase the temp, we're going to be shifting to the left because it favors the endo. If it's endo going this direction, that's the way we shift if we increase the temp. Okay? So, I don't want to confuse you though, because it's hard to just say it and not do an example. So, let's see what she keeps saying.
Therefore counteracting the imposed stress. Decreasing the temperature would cause the system to produce more energy. Therefore, the exothermic reaction would be favored. The dimerization of nitrogen dioxide to dinitrogen tetroxide.
So decreasing temperature, exothermic is favored. Decreasing temperature, exothermic is favored. So decreasing temperature, exothermic is favored. So again, you can write it. It doesn't make any sense yet, and I'll get to examples here.
Is an exothermic reaction. Nitrogen dioxide is a brown gas, whereas dinitrogen tetroxide is colorless. What observations do you think can be made when the temperature is decreased?
So this is exothermic. Stay with me. Exothermic. Here's your reactant. Here's your product. Here's your reactant. Here's your product. It's exothermic. So the energy would be over here on the right, but it's exothermic and temperature is decreased. So when temperature is decreased, she said exothermic is favored. Exothermic is favored. So you have to think, which way is this going to shift? Let me explain one more time. Here's your reactant, here's your product. This is where the heat would be. Exothermic is going that way because the forward would have the heat on the right. That's your exothermic, going to the right. So she said when temperature is decreased, you're favoring the exothermic. So are we shifting right or are we shifting left? Anybody want to take a guess here? Justin? Shifting right. We're shifting right. So we would expect to see more of the colorless. More of the colorless. So if you heat up a reaction that is at equilibrium, cool down a reaction that's at equilibrium, and if you get cool, it gets clear, and if you get hot, it gets dark, that means it's exothermic, because we're shifting and making more of this when it gets colder. Again, it might be a little confusing, that's okay, we're going to get some problems here.
How about when the temperature is increased? Please pause the lesson to think about this and resume once you are done.
We just did so.
A decrease in temperature favors the exothermic reaction, so more dinitrogen tetroxide is produced. Since it is a colorless gas, the mixture should appear paler. An increase in temperature favors the endothermic reaction, so more nitrogen dioxide is produced. The mixture should therefore appear darker brown. Addition of a catalyst does not affect the position of equilibrium as it increases the rate of both the forward and reverse reactions. It only quickens the attainment of equilibrium.
So I'm going to stop there. If you add a catalyst, it doesn't alter the equilibrium at all. What does it do? It just switches faster. It doesn't tip, the seesaw doesn't change, it stays balanced. It just transfers faster. So the shifting occurs faster in both directions, so a catalyst does not change the equilibrium. It just allows it to work faster. So that's something we're going to write as well. Alright, so light quiz. You can leave those down for now. Let's just get to this. I don't want to run out of time. So let's do a quick example here. Let's use that same example we've used before. N2 plus H2 yields NH3, and it's plus 90. They gave it whatever. 98.6, I think, kilojoules. 2 here and a 3 there. So there's our energy, 98.6. So is this exo or endothermic? Exothermic. Good. Okay. So here's the question. If temperature is increased, in what direction will the equilibrium shift? In what direction will the equilibrium shift if we increase the temperature? So the way she taught it, she explained it, was when you increase temp, it favors the endothermic. What direction is the endothermic? This way. That's endothermic because then the energy would be over here with the reactants if we're going this direction. So we shift to the left. Here's another way to explain. Some of you might be confused. So listen, because I'm not going to be able to get another example. I treat temperature as if it's part of the heat. What does that mean? If we increase temp, I in my brain say, I'm increasing that number. So if I add more to this, what happens to our balance? If I add more over here, this side goes down, right? So how does it have to shift to go back to being balanced? It has to shift left to go back to being balanced. So that's another way I teach it, is saying if we increase temp, it's like making that number bigger. If we decrease temp, it's like making that number smaller, so it becomes lighter and we have to shift to the right. So I ran out of time. I apologize. That's the only example I got, so it's going to ring real soon. Give your homework worksheets a shot. That's due Monday. Please do them, okay? Don't let the weekend ruin your brain. And that's it. And I will be after school. If you need anything, I will be after school.